about to start our new block of lessons with our fifth graders on a completely different topic. We're going to be studying heat, and our challenge is going to be to build an energy efficient house. And we're actually going to have a little competition of building tiny little houses out of cups and see how they perform when we shine a bright sunshine onto them and see which one stays the coolest. Now, just a quick note, of course, that these are new fifth graders that we're rotating through. They're teaching an entirely new group of students that you've never met before. So that means you're going to need to work a little bit on building that community that you started to build with your students last time. Get to know their names and at least try and develop a small relationship, even though it's a brief one with them. Once you do that, you're going to kind of push that relationship a little bit as you try and get them to play along with this role playing, the script that you can find the file in the same directory as the lesson plan is in, and it just sort of introduces this concept of some houses are too hot, some are too cold, some are just right, and what about the house's construction allows that to happen? And these four students have this discussion to figure this out, and what the issue is to sort of frame the next couple of lessons. And we end with this question of what is it about Ali or Ali's house, depending upon whether it's a boy or a girl, what is it about that house that keeps it cool in the summer and warm in the winter? And that is the topic of what we're doing. But of course, in order to actually accomplish that understanding, we need to know a little bit about heat. And that's what we're going to start doing, is trying to figure out what's the difference between hot and cold, and how does heat flow and heat transfer work. And to do this, we're actually going to use an ice cube to get started. We're going to have a series of small little mini investigations where you're going to feel things. So I want you to actually pause this video and go get an ice cube and bring it out here and put it on your hand. You ready? Okay, so I've got one here in my hand, and what do you feel in that right now? Oh, okay, you feel cold. So where's that cold feeling coming from? Oh, from the ice cube, yeah, duh. But what we're trying to figure out here is how does your hand get cold? In fact, in particular, does the cold go from the ice into your hand? Or is it the other way around? Does the heat go from your hand to the ice? And you can kind of think about that and ask also this related question here, which is on the previous slide. After you put the ice down, it doesn't feel quite as cold anymore, and slowly but surely your hand feels less and less cold. Where does that coldness go? Where does it go after your hand starts to feel normal again? And at this point, we're just trying to get our students and us to think about these things. And in fact, if we start talking about coldness moving, it turns out, as we're going to see in a little bit, that coldness isn't actually something that exists. But you don't want to tell your students that yet. You're just trying to get a sense of where we are and how to think about hot and cold. The next couple of activities and experiments are going to help us move towards a better understanding of that, a lot like the guided inquiry activities that we did when we were using those handouts in class. So let's say you put your hands in mittens on a cold day. Your hands warm up. How exactly does that work? How do those mittens do that? And to try and sort of probe that, we have this little mini experiment. We're going to take two thermometers and we're going to bring them into the room. We read them and they both say 74 degrees. That's the temperature in the room. We're going to leave one right on the table, and the other one we're going to stick inside a mitten and come back an hour later. The thermometer on the table still says 74 degrees after an hour. It's the same temperature as it was because the room temperature hasn't changed. But the question is, what will the temperature inside the mitten be? And what you're going to do here is you're going to actually divide your students up into two little mini groups. You've got two teachers, and you're going to have them each come up with an answer and tell you the justification of their answer. And so there's maybe going to be 2 or 3 students working with each one of your teachers. This will just allow us to have each student say what they think in less time, twice as fast. and everybody will get a chance to participate in that. And so what I want you to do is first commit, which one do you think? Why? All right, you ready? So when we actually go ahead and pull this other thermometer, the second thermometer, out of the mitten, which you'll actually be doing, it's going to say it's the same temperature as the other mitten, or as the other thermometer. And what's going on there? Why was that? Well, to really answer that question, we're gonna have to make sure that we work up to it. We'll be back to this question in a little bit. But to help get us there, we're going to use an analogy. You've probably seen these on crazy standardized tests, and they actually do have a purpose. We're going to create an analogy between heat and light. And the reason we're going to do that is because both of them are forms of energy, and we're just a little bit more familiar with light than we are with heat in some ways. And it's a little bit easier to talk about because, well, you can see it. So we're going to try and say cold is to dark or bright as hot is to dark or bright. This is a pretty easy one. I think all of you should get this because, of course, usually you probably think about this in terms of light bulbs, and light bulbs often give off both light and heat when they're on, and they don't give off light and heat when they're off. So you should get cold is to dark as hot is to bright. And what that means is this. I like to use this quote here. It's, all the darkness in the whole world cannot put out the light of a single candle. So when you turn off your light, it stops giving off light. Eventually it will stop giving off heat. It takes a little while for it to cool down. But it doesn't ever start giving off darkness or start giving off cold. The opposite of hot is cold, but what that means is that hot means you have a lot of energy, while cold means you don't have very much. So what that means is we actually have an answer to one of our earlier questions, finally. Heat flows from hot to cold. The heat flows from your warm hand into the ice, not the other way around. The coldness does not flow into your hand because coldness is just less hot. It's just the less energy. And we, just like when we had kinetic energy, where we have a lot of kinetic energy, it gets transferred to the thing that has less kinetic energy. The higher speed thing transfers energy to the lower speed thing. The hotter thing transfers energy to the colder thing. So once your hand has energy leaving it, it has less energy in it, which means it feels colder. That's why your hand feels cold. You've given away some of your energy. The next thing we're going to do is we're going to try and establish one other key thing that's going to be essential to understanding how to build our energy efficient house, which is that heat travels easily through some materials but not through others. And you can do this if you go and get your ice cube again and get a little sheet of aluminum foil and stick that in between the ice cube and your hand. What do you think is going to happen? How's it going to feel? Well, it's still going to feel cold because heat travels easily. So the heat is going to leave your hand and go into that ice cube through the aluminum foil. But if you switch out that aluminum foil and instead put a cloth there, heat might try to leave your hand, but it can't go through the cloth very easily. And so it basically sticks around. Well, what else do we know that's made out of cloth? Oh yeah, the mitten. So how does that work? Well, the mitten, of course, is made out of cloth, like the cloth experiment we did, which isn't going to allow heat to transfer through it very easily. So when you stick your hand inside a mitten, your body is going to constantly bring in warm blood that's going to sort of add energy into your hand. And that energy isn't going to escape. The heat energy is not going to leave because it can't get out very easily through the cloth. And over time, your body keeps pumping in more and more fresh, warm blood, and heat builds up in there, and your hand stays warm, even if it's cold outside. But with the thermometer, we didn't put put a heat source inside, we just stuck the thermometer in. So whatever heat it already had, the 74 degrees worth of heat, is going to stay in there. It's not going to get any extra heat from outside. It's not going to have any heat escape. So whatever it started with, it's going to end with, is the basic idea. And that's why you end up with the 74 degrees inside and outside the mitten, not the same as when you're wearing it. So all these little mini activities and discussions lead us to three key take-home messages. The first is that heat is a form of energy. And the result is, when we're talking about the word hot, we just mean an object has more heat energy. And cold means that it has less heat energy. We also saw that heat naturally wants to flow from hot objects to cold ones. But key idea number two, that travel can be impeded by certain materials that heat doesn't travel very easily through. And the last key idea is really the theme from our entire course. It's that you can only change temperature by interacting with something hotter or colder. So is it surprising that when we slid the thermometer into the mitten, it didn't change temperature? No, because the mitten was preventing any interactions. The only reason that our hand gets warmer when we put it in the mitten is because the hand is constantly interacting with the rest of our body, which is bringing in new blood and adding energy. So let's bring it full circle back to the energy efficient houses and the role playing that we did. How can we end up with a house like Ali's that's just right, the just right temperature all the time? Well, what we're going to want to do is, in the summertime, we're going to want to make sure that the heat stays outside the house. And in the wintertime, we're going to want to make sure the heat stays inside the house. So all we need to do is make sure that around the outside of our house, we have some sort of material that prevents heat from traveling in either direction. And that's called insulation, and that's how we build an energy efficient home. So the next couple lessons that we're going to do, we're going to explore